Good morning. Today we will start with our fourth module. Okay, that is wireless sensor networks. So today we will discuss about overview of wireless sensor networks. Okay, challenges for wireless sensor networks. Okay, then the technologies which enables the wireless sensor networks. Okay, so first we need to know what are wireless sensor networks. Okay, so the event, okay, the its applications, wireless sensor networks, where it is used. Actually, when we study about where it is used, we'll come to know whether sensor network, okay, it consists of which all components or equipments, and those equipments are known as what. Okay, so that one by one we will be studying. So now coming to application, first one is event detection. Okay, so these sensor nodes, see what about what is this node, that we, whether it is only a sensor or it has something more than sensor, that we will study in detail later. Now you consider it as one endpoint. Okay, one end entity, node. So sensor nodes should report to the sink is the destination point once they have detected the occurrence of a specific event. Now if you have put any sensor nodes, okay, so for which purpose you have put the node, that the event when it occurs, then actually the data or the result or whatever it is, okay, the information has to be reported to the sink is the entity which is on the other end. Okay, see, this is just sensor nodes. Later we will categorize it as wireless sensor nodes. Okay, so sensor node can be wired also or wireless also. Next, some applications can be like periodic measurements. Okay, it can be programmed with the periodically reporting measured values. Okay, maybe for 1 hour or 1 minute. Okay, or per day. So like this. Okay, once in a day. Okay, once after each hour, the measurement or the values, whichever whatever it has detected, okay, that has to be sent to the sink. Okay, these reports can be triggered by a detected event. Next, it can be used for function approximation and edge detection. Okay, the way physical value like temperature changes from one place to another can be regarded as a function of location. The wireless sensor network can be used to approximate this unknown function using a limited number of samples taken at each individual sensor node being at the edge. Okay, that means now it continuously changing values are there. Okay, if continuously variables varying values are there, then actually how to take the values. So it does the approximation. Okay, how does it do the approximation? It makes the sample. Okay, it makes it as a sample, and then sample averaged value is taken and it is sent to the sink. Okay, so that is also possible. Next, for tracking. Okay, nodes, yeah, sensor nodes is used for tracking, that is a remote sensing. The source of an event can be like moving, okay, mobile or something like that. Now, or see, it can be like at the borders. Okay, surveillance scenario, like there the sensor continuously need to monitor whether any moving object, okay, is entering in the within the border. Okay, so tracking, that is for such application also, wireless sensor networks, okay, is used. So once it detects, okay, it report the updates on the event to the sink. Okay, so along with that, see, this is optional again. It can it can estimate the speed and the direction of the object. It can also find the speed and direction of the object. Then what are the challenges for the wireless sensor networks? Okay, now, handling such a wide range of application. Okay, this is hardly possible with any single realization. That's why I said later we will see what are these nodes, wireless sensor nodes, N. Okay, so nodes includes many other entities because it is difficult to manage with a single entity. Certain common traits appear, especially with respect to the characteristics and the required mechanism of such system. So that is also a challenge. Now, required characteristics of the wireless sensor networks are okay, types of service. The sensor network is expected to provide meaningful information, okay, and actions about a given task. So it has to the whatever the data it is sending, value it is sending, it should be meaningful. Okay, so that is a type of service it should give. Additionally, concepts like scoping of interactions to uh, specific geographic regions or time intervals will become important. Then quality of service, that is also important. In some cases only occasional delivery of packet can be more than enough. Okay, in other cases very high reliability, so that means a continuous delivery of the data is required. So depends on the application that it has to be configured. Okay, in some cases delay is important when an actuator are to be controlled in a real time fashion by a sensor network. So this is also one characteristic. Okay, amount and quality of information that can be extracted at given things about the observed object or area. Now amount of information what it gathers must be high. Okay, quality of information what it gives should be good. At the same time, the number of bits what it is using to convey this should be less. Okay, I hope this point is clear. Okay, next it should have fault tolerance characteristics. Okay, so what does it mean? Nodes may run out of energy. This is one of the main and major concept which everybody are bothered about. Okay, well, designing the wireless sensor network. Okay, or might be damaged, or it is permanently disconnected from the other nodes. Okay, in such cases how to withstand all alone is the actually fault tolerance, and that should be high for the nodes. Okay, it is important that WN as a whole it is able to tolerate such faults. See, it is for indefinite time it to tolerate or to keep or to save that data may not be possible, but to the maximum extent of time. Okay, now if the connection established is lost, okay, then if it is in the remote area, this node is at the remote area. Okay, then if it is able to handle the data, collected data only for 10 minutes, then it may not be a good system, because since it is a remote area, in 10 minutes you cannot replace or you cannot re-establish the connection. So in that case the data whatever it had collected is lost. Instead of that, okay, if you design a system that is an individual node in such a way that uh, during this fault time, if it is able to handle it for maybe around 12 hours, okay, then it is actually more reliable, we call it as, because until we make the corrections to the um, what is that communication between another node. Okay, it is having the data, it is storing the data. Okay, so it is actually later we can retrieve that data once the connection is established. Okay, to tolerate node failure, redundant deployment is necessary. Okay, here how actually it can be overcome this problem. What idea is used is more nodes than it would strictly required if all nodes function correctly. Okay, to do a particular task, if 3 nodes are required, then actually you will deploy around 4 nodes. Okay, one is kept as a what you call one is kept as a side by. Okay, that is whenever if any failure occurs, then actually that node will come into picture. Okay, so your system will survive. So that is possible. Okay, now how should be the lifetime? In many scenarios, nodes will have to rely on a limited supply of energy, okay, using batteries. So now replacing these energy sources in the field is usually not practicable, and simultaneously a wireless sensor network must operate at least for a given mission time or as long as possible. That okay, if the event is given, at least for till that event happens once, okay, the WSN should be able to sustain on its own. Okay, so such energy resources, now most of the time we see that actually the renewable energy is only there, the research is going on to to use that those renewable energies to store it in the remote wireless sensor networks, because supplying it from a station base station, okay, may not be practically possible every time. Okay, so to overcome this, now, the lifetime of a sensor network becomes very important figure of merit. Okay, the energy efficient way of operation is always under research. How actually energy efficient uh, transmission can be done. Okay, because the storable capacity of the remote node is always less. Okay, because if you ask me why that, one is actually it should be like very compact. So when you design the complete node in a compact way, then you cannot think of a very huge battery. Okay, second thing comes the cost. Third thing comes the battery life, how actually you reuse those batteries. So for all these, you have to think, you have to find the lifetime of the sensor node. Next, it should have a good scalability. What does it mean? Okay, uh, it now when we talk about a network, it may include a large number of nodes. Okay, sensor network may include a large number of nodes. The employed architectures and protocols must be able to scale to these numbers. Okay, in case of reduced energy, okay, when are you scaling it down? Okay, when actually certain fault occurs or any certain situation occurs where you have to work with the reduced energy. Okay, in that case you need to scale it down. That means what do you mean by scaling it down? By eliminating one node, okay, your functions in the network should not alter. That is actually scaling. Okay, so see, when the nodes, suppose 10 number of nodes are there in the network, 10 nodes have 10 different functions, okay, or operations to execute. Now, due to the reduced energy working scenario, you are eliminating two nodes. Now 8 are remaining. So these 8, okay, it was dependent on the other two nodes which you have eliminated, but in this scenario it should be able to cope up, okay, with the absence of those two nodes. That is actually scalability. So wireless network should have this high scalability feature. Okay, next is a wide range of densities in a sensor network. The number of nodes per unit area is the density of the network can vary considerably. Okay, so that is actually how many nodes you are going to put it in a area. That area depends on the application. I can count it in kilometer wise. Okay, I can count it in just uh, meter square. Okay, depends on which type, or the sensor, sometimes the sensors are placed very nearby. Okay, so depending on the application which this thing we are saying. Okay, next is programmability. Okay, it is necessary for the nodes to process information, but also they have to react flexibly. to the changes in the task. If a slight change is there in the task, okay, then actually the present node itself should be able to handle it. For yesterday you had one this thing task. For that you used one sensor node. Today that same task but little bit different in type of information you require. Now if you are expected to put like deploy another node in that, then your system is not efficient. Efficient system is the one, okay, where actually the same node can be used, can be programmed again to uh, suit to your uh, requirements. Okay, these nodes are programmable, okay, and their program must be challengeable during operation when new tasks become important. Okay, a fixed way of information processing is insufficient, okay, or it is inefficient. Next, maintainability. Okay, the environment where actually wireless sensor network works is actually challenging. Okay, the depleted batteries, then sometimes node failing, sometimes communication errors, okay, something like that. So the system has to adopt these changes, okay. So along with that it has to monitor the health of the entity, that is the node. Okay, health of the node is actually it can't run beyond certain level of parameters. Temperature, it can't go higher than this. Okay, let the task be anything different, let it adopt any programs for that. But okay, while executing that task, if the temperature is exceeding, okay, from that level, upper limit, then actually it has to be taken care. In a sense, the node itself has to take care, maybe switching off, maybe sending some warning. Yesterday we have learned, okay, many this thing, how actually warning and all can be sent from the remote area. So warning is sent that the temperature is exceeding the level. Okay, suppose that it is some task is drawing a lot of energy. Okay, some task is drawing a lot of energy. Okay, that time this thing, what is that notification, the energy level has come down than the below than the threshold level. So that one, so that actually comes not for all the this thing, not for all the application, for few application it comes. So in that time, the system, the which system, the node itself has to monitor its health. Okay, it should be capable of doing it. Uh, if any, that's what, if any changes are there in the maintenance mechanisms, then it has to convey it to the external what is that, external entity, or we call it as a sink. Okay, so it should do that. Now coming to the mechanisms to realize wireless sensor network. Okay, so innovative mechanisms for a communication network have to be found, as well as new architectures and protocol concepts. Okay, so why again we came to a particular different protocol, because now we are uh, concentrating on the wireless. Till now whatever I have spoken, that is challenges, features, advantage, applications, anything, so that was common for sensor network. Now when we come to wireless sensor network, the protocols are different, and this is like everybody knows that, so you are familiar with few of them. Okay. Now, multi-hop wireless communication. Wireless communication is a core technique. A direct communication between a sender and a receiver is faced with limitations. Okay. So, communication over a long distance is only possible if uh, transmission power is high. Or else, what do we do? If the transmission power is not sufficient to uh, put the message till the receiver, then what do? We go for relays, intermediate relays. What happens at the relay? Okay, and it is the signal is boosted. Okay, along with that, actually you can do many other procedures. Okay, maybe you can after that we can go you can go after that relay point, you can go for different type of modulation techniques, or okay, you can go for different type of encryption. So those are also possible, depends on the security or whatever this thing you have, requirement you have. But actually after doing any required thing, what it does, it totally boosts the power of the signal. Actually you find this most like very easy example what I can give is the satellite. Okay, at the satellite you have a transponders. What does a transponder do? It receives the signals from the earth. Okay, then by the time it reaches there, it would be very feeble. Okay, it very feeble. So it clears it from the noise as much as possible. Okay, then it changes its frequency, because it is going to send it back to the receiver. Now when it is sending it back to the receiver, if it sends in the same frequency, then actually there is a possibility that it might interfere with the upcoming frequency. Okay, because upcoming frequency is coming in upcoming signal is coming in one frequency. So when it is going down to the receiver, if the same frequency is maintained, then there is a possibility of interfering. So you change the frequency conversion again takes place. Okay, then maybe encryption. Okay, different type of encryption may happen. Okay, it is not necessary that the same encryption has to be maintained. Okay, so that conversion also, different amplitude sorry, different modulation technique you can adopt. Then actually power is given to it, then it is sent. So that is possible. Okay, next uh, energy efficient operation is one of the main feature. Okay, it is to support long lifetimes. Okay, then uh, that's what to support the long lifetime of the nodes, we go for the different techniques to save the energy. Okay, next is auto configuration. Now this, the name itself, the word itself tells auto configuration. It has to configure most of its operational parameters autonomously. Okay, independent of external configuration. Each and every time the wireless sensor network need not be controlled from the remote base station, or need not be in the sense should not be, because for controlling again you cannot waste certain bandwidth. Instead, if the wireless node itself has the ability to configure itself, then actually the job becomes easier. Okay, the bandwidth again, we save the bandwidth. The bandwidth we give only for the transmission of the data, not to configure the nodes. See here, one of the example is nodes should be able to determine the geographical position. Okay, only using the other nodes of the network. It should not wait for the command from the uh, uh, remote control unit. Okay, now collaboration in networking processing. Okay, in some of the application, a single sensor is not able to decide whether an event has happened, but several sensors have to collaborate to detect an event, and only the joint data of many sensors provides enough information. So it should work in collaboration. Okay, so maybe uh, maybe to determine like uh, let me tell you, wait, weather forecasting. Okay, if I say weather forecasting, like you may have sensors at a different places, different sensors. Okay, one may be to find the depression. Okay, or one may be to find the speed of the wind, one may be to find the rainfall, amount of rainfall. So with all these, okay, you can, the controller will come to the conclusion that what is the predicted scenario. Okay, different sensors working together for a single task, but doing the performing the different operations. Okay, information is processed in the network itself in various forms to achieve this collaboration, as opposed to having every node transmit all data to an external network and processes at the edge of the network. Okay. Okay. Next, it should be data centric. Okay. Now, traditional communication networks are typically centered around the control system. Okay. Now, when in that was traditional this thing, it is you are uh, starting your communication with the address. Okay, centric. First, you send the address, then you identify that it is the authorized node, then you start sending. But in a WSN, where nodes are typically deployed redundantly to protect against node failures or to compensate for a low quality of a single node actual sensing equipment. Okay. Now here what is important is the uh, which node has provided them the assistance when it had a fault. Hence, switching from an address centric paradigm to a data centric. Okay, so the difference is in traditional communication network. Okay, traditional communication usually it is wired. So in that case, if any fault is there, that is identified by the controller only. Okay, and the controller assigns that work to the other node. Okay, other node to perform that task. So in this present scenario, wireless sensor, if you take, it is not like that. Okay, it is the fault occurred in the one node is sensed by the other node, and uh, other node does the job of the this fault node. Okay, next comes locality. So the principle of locality, okay, it has to be embraced extensively to ensure in particular the scalability. Okay, so scalability we have studied. So nodes are very limited in resources like memory. Okay, it should attempt to limit the state that accumulate during protocol processing to only information about their direct neighbors. Okay, so these are actually some of the constraints. Then exploit trade-offs. Higher energy expenditure allows higher result accuracy, obviously, but okay, longer lifetime is also there, but okay, trade-off is required uh, against the lifetime of the individual node. Okay, now what are the enabling technologies? Okay, it is first it should be, as I said in the beginning, it should be miniature in the hardware side. Okay, smaller size in chips have driven down the power consumption. So once the size becomes smaller, the power utilized also becomes lesser. Okay, of the basic components of the sensor node. So construction of WSN is challenging in this aspect. Okay, smaller size, relevant to microcontrollers and memory chips. Uh, but also radio modems, okay, responsible for wireless communication, have become much more energy efficient. Okay, one of the major reason for energy efficient is the small size only, that is a reduced chip size. Okay, so in turn it reduces the cost also. Okay, yeah, sometimes we say that the initial cost is high but later the cost becomes low, but on the whole the cost is reduced once the technology comes into the market. Okay, so for that reduced size, what is the processing and how is the communication? Okay, then how should be the sensing equipment? Okay, what is the relevant technology used for that? So that should be adopted for the wireless sensor networks. So in this side, one this thing we have to say is the single node. Okay, we will be studying about the single node, what are the components in the single node and all. So that we will study in the next class. Okay, thank you.